Hey guys, welcome to the last video in this semester. We are going to finish up talking about the search for intelligent life here by talking about something called the Drake equation. So the Drake equation is a way to sort of mathematically try to figure out, are there other intelligent life, civilizations, nearby in the Milky Way. So hopefully you watched the previous video where we talked about the messages that we've sent out. So some people do think there is life out there to receive those messages. And then maybe you watched that Veritasium video, are there aliens, which is a pretty good video, just sort of gets people's opinions, but also reviews some of the stuff we've talked about. And so here we are at our last video. This is Frank Drake, the one on the top, not the one on the bottom. And in 1960, he put together some factors to estimate not just if there is any intelligent life anywhere, but very specifically to estimate the number of advanced civilizations. So these would be people that we could actually, creatures we could actually communicate with. Okay, advanced civilizations, they have to have the technology that they can send signals or receive signals. And they have to be close enough that we can maybe make contact. So that means that they are in the Milky Way, which isn't all that close. If you remember, the Milky Way is 100,000 light years across. We're 25,000 light years from the center. So maybe not make contact anytime soon, but at least it reduces the number. Because remember, our Milky Way is one of only billions of galaxies. So if we were to extend this to the rest of the universe, it would be a little bit unwieldy. So he asked himself, Frank Drake, if we were going to make contact here, what are some of the important factors that we need to consider? And the first ones will be based on science that we have pretty good estimates, and you'll see some of the things that we studied this semester go into this equation. Okay, so here's the full equation. Don't worry, you're not going to have to put numbers in it, but I want to explain what each of these little letters mean, the R and the F's and N's and all that. So the big N here, right, this big N, this is the number of advanced civilizations in the Milky Way. And so in order to get that number, we're going to multiply a bunch of factors together. And I'm going to go through them one by one. Okay, so the first factor that you see is that R star there is the number of suitable stars. Oops, sorry. I misspelled suitable there. Not suitable, but suitable stars. The number of suitable stars. And what's a suitable star? Well, hopefully you remember a couple of videos ago when we talked about the habitable zone. And we said, well, if it's a really massive star, it's not going to live very long. If it's a really cool star, it's going to have a really small habitable zone. So factors like that, stars like our sun, smaller stars. And it's not just the number of suitable stars that are out there, but we're going to put time in this equation. It's the number of suitable stars that form in a year, in a particular year. The reason why we're going to put time in this equation, and time will come back at the very end too, is because we want to make contact, right? So if these stars formed 10 billion years ago, then there's not much chance that if a civilization came and went, who cares? We're never going to contact it. So this is a number that we can estimate pretty well. The number of suitable stars that form each year in the Milky Way, remember we're located in the Milky Way, is approximately 7. Right? That may seem like a low number, but remember stars take a couple million years to form. They don't turn on instantly all at the same time. So this would be ones that start to shine, start to produce energy and light through fusion every year. So about 7. Okay, so now we're going to go to the next 2 factors here. So, as you might guess, the next factor, so we have a star, it has to have planets around it, right? We want to see some of those exoplanets. So the next thing that goes into it is how many of those stars, the fraction of the stars, remember fraction is like, is it half of them? Is it a quarter of them? How many of those suitable stars have planets? And at this point, we're just saying any kind of planet. Big planet, small planet, whatever. Well, this is something we can also estimate pretty well. We look with our telescopes, we look for planets, and we see a lot of planets. We see almost every star has a planet. So we're going to give a range, anywhere from 50%, and I'm going to express this in terms of a decimal, so 0.5 would be 50% or half, all the way up to all the stars, 1. So 1 represents every star has a planet, 0.5 represents half the stars have a planet. Okay, so we have sort of a conservative estimate or a pessimistic estimate up to like a more optimistic estimate. Most stars have planets though, more than half. Okay, next is how many of those planets are really any good? I remember our exoplanet discussion again. Not all of those planets are going to be habitable. So I'm having trouble here today. The number of those planets around a suitable star that are habitable. So the number of habitable planets. And remember, habitable is not just in the habitable zone. It has to be the right size. We don't want it to be too big or too small. And we want it to have a good, stable, circular orbit so the temperature doesn't change too much. So the number of habitable planets per star. Well, we have 1 in our solar system out of 8. We look at other solar systems and they might have 2 or 3 habitable planets. So we're going to say 2. Sure, why not? Okay, we might have had 2 in the past. Mars might have had more habitable features in the past. So far we have how many stars are suitable, how many have planets, and how many of those planets are habitable. We are pretty good at estimating these numbers. These numbers are fairly solid. I mean, they could change, of course, but not too bad. Now we're going to get to the second half of the equation, and there's a lot more guesswork that goes into the second half of the Drake equation. Remember, we're trying to figure out advanced civilizations in the Milky Way. So not just planets with microbes, but we're going to start there. So of those habitable planets, how many actually have life? Okay. So far, we've only found 1 planet with life, and that's Earth. So this is a bit of a guesswork. We don't really have much to base this on. So the fractions of the planets with life, and this is any kind of life, any life form at all. We're going to find a much bigger range here because we just don't know. Is it 10% of the planets? So that would be 0.1 would be our fraction. Or do all of the habitable planets have life? We haven't actually visited another habitable planet. Maybe they all have life. So again, we have sort of a pessimistic 10%, optimistic 100%. But again, we are reaching for the stars here, and we want not just microbes and plants, or animals even. We want intelligent life because we want to make contact. So this is the fraction with intelligent life. Okay, this would be the F sub I, the fraction with intelligent life. Now we look around Earth and we look at all the species on Earth and we see 1, maybe, that's intelligent. We see 1 anyway that can develop technology. We're not quite to the technology part. So maybe we can be a little more generous and we say, okay, well, dolphins are intelligent, chimps are intelligent, some birds, some dogs. So we can be a little more generous. So, but of all the species on Earth, that's still a very small fraction. So we're going to make this small. We're going to say 1%. So if you have life, think of all the insects, all the plants, all the life on Earth. We're going to say maybe 1% is some sort of intelligent. Uses tools maybe, or whatever your criteria might be. But we really want to go beyond that. And this definitely is just humans. It's the fraction of that intelligent life, and I don't think anybody argues with this one, the fraction that develops advanced technology. And we're kind of specific when we define advanced technology. The fraction of those intelligent life forms that develop technology that can talk to the stars. Okay, spacecraft, radios, these things that we've been talking about. So that develop advanced technology. So even if you're including some animals in your fraction with intelligent life, the fraction that develop advanced technologies can send messages and receive messages from space, that's a small number of a small number. So we say 1% is intelligent. Of that 1% of intelligent species, maybe 10% of those 1%, or if you're being very generous, maybe you say, given enough time, those dolphins and birds could develop space technology, any intelligent life form could develop space technology, and you would go up to 100%, right? Again, so you say only 10% of those life forms, or all. So, we've reached advanced technology, but let's put time back in the equation again. So here's where time comes back in. We want to make contact, right? So we have to include the number of years that this advanced civilization sticks around. Because light takes time to travel, we live in a very big Milky Way, so we want to know the number of years that this advanced technology civilization exists. Because that tells us, can we overlap with them? Civilization. Okay, number of years such civilizations exist on average. So we've had space technology for a little over 50 years here on Earth. How long are we going to have it? These, I think, are pretty optimistic estimates. Is it going to be 1,000 years? Okay, the Roman Empire lasted that long. The longest, Chinese empires and such last that long. So maybe we could have this technology for 1,000 years. Or if we're really being optimistic, we say humans have got it going on, and we are going to be able to maintain this level of advanced technology in some way for 1,000,000 years. Okay, so that's a big range, right? And we'll see how that range plays out. So all of this is based on humans and speculation and life on Earth. So these numbers, these ranges, are a little bit of guesswork, right? So if we multiply all this together, what do we get? Well, we get that big N. And that big N, the result of our calculation, is the likelihood that civilizations exist today in the Milky Way. We want to overlap with these civilizations. We want to know who is out there with us today that we could talk to. So, advanced civilizations exist today in our galaxy, not the whole universe, but in the Milky Way. Okay. So let's put those numbers together. Remember, a lot of them I gave you a range, the pessimistic to the optimistic. Let's take the pessimistic first. Look, here's Frank Drake. He doesn't look very happy. So if we multiply all those fractions out, and we take the lowest numbers that I gave you, we get that the number of civilizations in the Milky Way today is 1. Not one besides us. That is us, guys. That we are it in the Milky Way. That is what we call the pessimistic result. So that's for pessimistic. If, of course, you see finding aliens as the best result, this is the pessimistic result. Okay. N equals 1. We are alone. Remember, though, there are billions of other galaxies, so if you have one civilization per galaxy, you could still have billions of civilizations out there. Problem is, you'd have to go about 30 million light years to get to the next one, so that's a problem. However, we had a different range, right? Here's Frank Drake, he's smiling this time, and he says, what if we take the top numbers? The optimistic numbers, we get a very different result. We get, you ready for this? 15 million advanced civilizations in our galaxy. So 15 million is the optimistic estimate. Okay, if you are looking for life, these are the numbers that you want to pick. Optimistic estimates. This is saying that there is life everywhere, that it's intelligent, that the intelligent species can develop technology, and that they live a really long time. Another way to think about this, 15 million in our Milky Way means that there is one advanced civilization in every 10,000 stars in our Milky Way. That means that there would be life about 40 light years away. That is something that seems attainable, right? That seems like something that we could find, meet up with. However, we also have to ask the question, if it's only 40 light years away, how come we haven't made contact yet? So, are we alone? Pessimistic? Are there 15 million other people out there? Optimistic? I don't know. Nobody knows. Maybe one day we will make contact and we will know. All right, so that is the end. You have a couple of clicker questions here to finish out this semester, and then that is it, guys. I wish I could see your faces, talk to y'all, but hopefully I'll see a few of you with your projects. I'm looking forward to grading those. So I will see you all soon.